Hi everyone, I'm Mantegazza, and in this lighting talk I want to share with you a mapping project in the southern region of Utopia Planitia in which I'm currently working. As part of my PhD thesis, I'm studying ice-related landform in mid-latitudes of Mars, and this project is part of my research. Utopia Planitia is located in the northern plains and hosts multiple landforms indicative of ground ice, such as scallop depression, scallop terrains, texture terrains, and more. This project starts with the goal to map this kind of landforms at several regions of Utopia Planitia in order to understand the geological history and processes involved in their formation. But when we start looking through high-rise images containing pits or other kinds of depressions, we came across an interesting feature that caught our attention and changed a little bit the idea of the project. We took interest in this linear feature that extends for kilometers and exhibits variation in their morphology. Some of them are related with big craters, while others were found with scallop depression both in the inside and in the outside. So we sought to cover a bigger area that we think in the beginning and make a regional map to track the extension of and pattern of these linear features. So the first part of this project is generate a regional map to identify the main units and features of the area, and then we will produce detailed local maps for particular location to study more closely the linear features and the ice-related landforms. Since the projects involve two different approaches, we have two different mapping methods and datasets. We use low and medium resolution, such as CTX images. In particular, we use the mosaic provided by Murray Lab and also include CTX images to fill the gaps. We also use TEMIS data infrared global mosaic and topographic information from MOLA. For the local mapping of smaller areas, we use high-rise that are high-resolution images and digital elevation model from high-rise. So this is the area selected for the regional mapping. To this map, we decided that the best approach to optimize the regional mapping was to first generate a uniform grid to divide the extensive area into a smaller section. This way, we can map one cell at a time and move forward with the mapping step by step. And then we set up the map scale to make sure we don't get lost in the details. For this, it was important to keep in mind the main goal of the project, that is to map the units and the geomorphology of the area and track the linear features. Having a wide dataset with different types of information is useful to define units that may not be fully defined using only one type of image. For example, in this case, to define the ejecta layer of this impact crater, we based on the difference detected in the CTX images, but also in the TEMIS and MOLA mosaic, to define more clearly the edges of the units. So, as I said at the beginning, this is a project that I'm currently working on, so sadly I cannot show you specific results yet. However, here I show you a part of the map. This is one of the areas with the highest density of these linear features. We can already observe some particular characteristics and patterns. For example, that these features are not continuous. Although they are features that extend for several kilometers, they often vanish and then reappear. Once the map is finished, we will be able to see the distribution of the feature and the relations with the different units, in particular with the ice-related landforms. So thank you all for your attention and keep mapping.